Alright, so we'll talk about positive, negative radius values, adjacent elements, and tangent elements for NC surfaces. So let's say we're going to create a new part here. What? What? Oh, I think I timed out. Alright, let's try this again. I created a new part. I'm just going to go into the XY plane. Oh, you can't see it. I forgot. It kicked me out. And when it did that, I lost the share screen. So, is it back now?
Yeah. Yes, I'm back now.
Okay. I'm going to go back. Oh yeah. I'm going to go create a sketch on the XY plane. I'm going to create a rectangle. Let's constrain it. Remember to always create your rectangle and constrain it before you do your corners. And we'll do a 1/2 inch radius. So let's move this out. Oh, you know what? Here, we'll make this a pocket. So I'll create a pad. Looks close enough. I'm just going to constrain it to the axis real quick. Let's try the multi-pad feature. Let's try changing limit 2 to 1 inch and limit 2 for the second one to a 1/2 inch. Oh, sweet goodness. Let's see. We want to go 1 inch minus a 1/2 inch. Okay. So this is a 1/2 inch radius. What size cutter would I want to use to cut out this pocket?
A 1-inch cutter.
So if I were to put in a 1 inch cutter,
You have 1/2 inch radius, correct?
in theory, so let's talk about this.
Okay.
This line and this curve and this curve and this line and all the way around, are all the curves and lines adjacent? Meaning, does this line and this curve touch at the same point, where they share the same point at each ends of the radius going into the next line?
Yeah.
So they are adjacent. And then, are they tangent? Is this curve and this line tangent?
Yes. Yes.
Well, that is all correct. So So a lot of times you'll hear people say you have to have adjacent and tangency in order for us to machine this. So great, that is great. It is all looking like it will line up perfect. So I'm going to use a 1/2 inch cutter. Sorry, a 1-inch cutter. And let's just say it starts at this point. If I'm using a 1-inch cutter, what is my radius? I do a half. What did I do? Half inch. If that cutter goes into this curve and machines this, it's going to be perfect, right? It all looks perfect right there.
No, it's gonna chatter.
Yeah.
Yeah, there's gonna be some error.
Because if I...
Yeah, wouldn't you want to cut through it with a little smaller diameter?
Yep. So if I go, whoops, 1/2 inch here, in order for my cutter to get from this point to this point, right, as I'm coming along this, I'm going to turn that grid off. Whoops. This is fitting tight, exactly perfect. If I start here and machine here, it's going to fit tight, exactly perfect in here. When this cutter travels down to this end down here, gosh
Well, we
damn,
all know the world's not perfect, right?
hang on. I'm jumping back and forth trying to change all these windows. So when this cutter comes down to this point here, oh, you piece of... And then it goes over to this side. Where are you? Coming from this point to this point represents, anybody know? What does this axis represent?
The center line of the tool path.
Yes. It represents the tool path itself, right?
Yeah, it's the right angle turn.
Exactly. So when you have these tool paths, this is the tool path it's going to follow, right? It's going to probably start here, but just for the sake of argument here, we're going to start here at this corner. We're going to go here. We're going to be fine until I start going down. And then I start to go left, and I start to go up. The problem is, right here, this is tangent or not.
It is not. No.
And it's not adjacent.
Well, it's sharing one point, so isn't it adjacent?
It is adjacent. It is indeed, it is adjacent, but it is not tangent. So when you hear the term, you have to have tangency and you have to have adjacent. It's not in the engineering part itself, it's in the tool path. If the tool path does not have tangency and adjacent, you're going to have issues. And what's going to happen is it's going to come along here and it can't just smoothly make the corner. It stops and then starts again. When it stops and starts at that corner, it chatters on that corner, and then you get a dig on these corners that you didn't expect. So what that would mean for me as a guy in the shop, I would have to change this radius or get a different cutter. Now, I'm just telling you, I was actually doing some fabrication on my trailer with the ex-Boeing guy, and he was talking about drill bits and stuff and tools. The 1/2 inch tool would be a certain price, but this next size down to get the biggest cutter I can, like it'd be 4875, like, I don't know, is that 15-30 seconds or whatever. To get the 15-30 seconds tool, you got to pay 4 or 5 times as much to get that tool. So the more common the tool fixture you can use, or cutter you can use, the cheaper it is for the shop. And plus, that's what most of them have, is they have the most common ones. The more you do tool changes, the more expensive the thing is. So how I used to get...
You want to run that for like a 3/8 or a 1/4 inch?
Yeah, well, if I do a 3/8, this could take me forever to pocket this, because I want to hog out as much material as I can as fast as I can. So this 1/2 inch radius, I would modify it to 0.53. Does anybody know why I'd modify it to 0.53?
So you can use that.
It's still within engineering spec.
Yes, if I change it to 0.53, it's still within engineering specs. I've machined it according to the engineering drawing. It could be up to 0.53, and I'm able to use my 1/2 inch cutter. Because by changing that to 0.53, what will happen to my tool path right here?
It can maintain tangency. and
Yeah.
efficiency.
Now, what I would recommend to the engineering is take that dimension and go to the next fraction that's the most common. Does anybody know what the most common fraction would be the next? 9/16, and that's 5625 is 9/16, right?
Yeah.
So if you change that to a 9/16 radius, and I wish it would have, oh, it did, it changed all of them to 9/16. That would change this radius. Why didn't one of these, this line here,
Oh. Might not have hit the center point.
yeah, I must have missed. Anyways, this wouldn't be a 90-degree angle anymore, because this will be a radius as it makes its turn of 0.0625 radius in here, which means I could get right up in there and machine that with a 1/2 inch radius. So on this Word doc, oh no. When I'm talking about elements being adjacent and tangent elements, that's what we're covering here. Adjacent elements, tangent elements are lines or curves itself versus surfaces. And the toolpath must be continuous in tangency. That's what I'm referring to. That toolpath does not come to 90-degree turns. Okay? So that's just a kind of a quick hit on why those need to be bigger radiuses. So I'm gonna auto search that. Oh, did you not get that? Can you not auto search axes? I guess not. All right, I want to talk to you about positive and negative radius values. To make this simpler, I'll make it 2-inch radius. Maybe that's too crazy. We'll go 1.5 inches. All circles are created how? Does anyone know?
Are you talking from 3 o'clock counterclockwise?
Yes, that is exactly what I'm talking about. So go ahead.
Well, yeah, the start point of all circles are at 3 o'clock, and then it draws them counterclockwise.
So if this were my center point, this point right here would be 3 o'clock. I'm going from 0 to 90 degrees. I'm going from 0, 3 o'clock, counterclockwise up to here. This radius value is a positive or negative radius?
Positive?
It's positive because it's going from 0 to 90. If I come over here, this curve is continuing. Is it positive or negative?
Negative? Because it's moving down as the graph?
From 90 to...
It's still counterclockwise because it's counterclockwise from here to here. Is that counterclockwise?
Yeah.
Then it's positive. That's a positive value.
Oh.
If I come down here, is positive to negative, right? I'm going positive or negative.
Positive.
Still going counterclockwise, and I come around here.
Same.
This is why I suggested I always make my curves counterclockwise, so that they show up as positive values when you analyze them, and it goes in the natural direction that CATIA wants to create them. Okay? Now, if I started machining here and I went this way, and then came over this way, and then came up this way, what direction am I going?
Negative.
I'm going in the negative direction.
Clockwise.
I'm going clockwise, and then all negative radius values. Okay? So, let me pop up another demo here. And I'll go into the YZ sketch. Turn my grid back on. Oh, I didn't have that on, no wonder. I'm going to create a line, and I'm going to create a curve. What direction is that curve, positive or negative?
Negative.
Sorry, the direction is clockwise, and therefore that's a negative radius, right? I'm going to go up to here and create another radius. That curve is a negative or positive value.
Positive.
And from here,
Positive.
come down here, positive. What the heck did I do? I didn't go up far enough. Okay, so this part won't be symmetrical.
Negative.
Now I'm in the negative. Why is this not behaving right? Sorry. Dang it.
Positive.
Up, David. Rookie. You didn't see that.
See what?
Exactly. If I had this part sitting on a tool like this, I got a 1/2 inch cutter and I'm coming along the side. Am I okay?
Seems like it.
Okay, so I can machine off this side of the face.
Mm-hmm.
Can I make this round with a 1/2 inch cutter?
Yep.
This face with the 1/2 inch cutter?
Mm-hmm.
And this face?
What was the angle? Half inch.
You're not okay.
Not clean.
So this face, and this face are okay, but once I get in here with my 1/2 inch cutter, what's going to happen?
You
It's
want
good.
to have 10 tool path.
It's going to chatter right here. Okay? So I have to change all these radiuses to 9/16, right?
No.
Depends on what you want, how you're designing it.
Yeah.
Well, for machining purposes, to get in and machine all these, I have to have them all 9/16.
Okay.
So I got to change this to be 9/16 and this to be 9/16. Otherwise, I could not machine it with a 1/2 inch cutter. Agreed?
No.
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 I don't know that I agree.
What
Yeah.
what would I have to change?
Just those two inside.
That one and the opposite side, right?
Yeah.
Yeah.
On my sketch, I would just want to change this radius and this other radius to 9/16. Okay? And then I could get in there and machine it. Now, we talked about the radius being positive and negative, all depending on what direction I'm going. So if my cutter's here and I'm going in this direction, am I going positive or negative?
Positive.
Okay? This face and this face, assuming it's 9/16. I'm going into this radius at a 9/16 radius, positive or negative?
Negative.
Negative.
This one's positive and this one's negative. And this one is.
Positive.
Positive. Yeah.
So we have negative and positive radiuses. Can I machine this part?
I mean, yeah,
Yes, I can.
Come up with a better path.
That's no problem. So on this sheet, it says you got to check for positive, negative values. Are the positive, negative values okay for this example? Yes.
9/16.
So that's perfectly fine that they're positive, negative values. It's not affecting the ability to machine the part. To see an example of it not working, we'll do another video.